Let's use Cancer Data Aggregator to find subjects with similar characteristics so we can build a simple cohort. To do that, we're going to head to the Cancer Data Aggregator website, which you will find at cda.readthedocs.io. Here, you will see that we have a number of options for how to interact with the CDA. You can use our interactive tool, you can use a low-code tool, you can install and run using CDA Python, or there's a number of options for developers at the bottom. In this video, we're going to look at the low-code option. To do that, we're going to click on the button that says Launch CDA in the Cloud. This has opened an ipython notebook where it is pre-programmed to summarize the subject metadata for subjects that have BAM files. I can run this as is to see how the results are made like they are in the website. To do that, all I would have to do is click this little play button that says Run All. Let's do that. It's going to pop up a warning and tell us that this notebook was not authored by Google. Because it wasn't, it was authored by CDA, so we're going to click Run anyway. As you can see, the little play button in the first box started turning, and now we're waiting for the code to finish running in this first box. This first box just installs Cancer Data Aggregator to our virtual machine so that we can use it to run searches. This search is going to be more powerful than the interactive search because now we're not constrained by our browser and we can search across all of the different fields that are available in CDA. We can tell that the installation finished because the spinning box went away and now we have a check mark that says 30 seconds, which is telling us it took 30 seconds for our install to run. If I scroll down, we'll find more boxes. And these have run as well. So box 2 took no seconds at all. Box 3 took 1. And if we go all the way to the bottom, we can see that it's still working on box 6. We'll let that run while we look at what is happening up here at the top. So the easiest way to think about how to use the Cancer Data Aggregator is to think of it as one very, very, very big Excel file. And if you were searching through a very big Excel file for subjects that have the kinds of data that you're interested in, you would probably look at all of the columns across the top so that you could see what kind of data there is to filter on. And then once you knew the columns, you would choose one and choose a value inside the rows of that columns in order to filter. And that is basically what we're doing here. We are asking what columns are available in CDA that are in a table that has to do with files, because we're going to filter by BAMs. And that brings up a table of all of the column names that belong to files and what kinds of information you can find inside of those columns. Since in this example we're looking for BAM files, we want something that tells us about the type of file it is. So file type is a likely option for that. This says that file data type is things like CT image or MI expression. That's not quite BAM, so let's try a different one. How about format? File format is things like JPG, PDF, or CSV. So if I think about the name of a file, it's usually something dot something. And here I'm looking for something dot BAM, which means I'm looking for the file format. So if I look here, there is a format column, and file formats, it says, are things like JPG, PDF, or CSV, which are the things I would expect to come after the file name and the dot. So that looks like it's probably the thing I want to search. Then I need to know what options there are in that format column. So is there a BAM option? To do that, I ask what the column values are for format. And it once again gives me back all of the entries. There's 60 different formats currently available in the CDA, and right now it's ordering them by value count. I don't care about that at the moment. I want to know whether BAM is in here. So I'm going to go to Format and hit the up arrow, which will change it to an alphabetical sort, and put BAM near the top. So here, BAM is an option, and there's quite a lot of them. So now I know that my search needs to be of format and it needs to be of BAM inside of that column. So I am going to build my query using that information. We're interested in finding subject data, and the only thing I want to match right now is format equals BAM. If I run this, I get back a number of subject IDs, over 35,000 of them, and a bunch of information about the subjects that have that data. You'll notice that there are fewer columns here than there were in the interactive search. That's because there are so many columns available when you're using CDA Python directly that we can't show them all at once. So if I want to look at more columns, I will have to add them on to this initial view. I think we can agree that looking at over 35,000 entries line by line is probably not very helpful. So perhaps a better way to look at this data would be to summarize it. So let's, instead of getting the subjects, let's summarize the subjects. And we're going to use the same match all of format equals BAM. Now I have a set of nice little tables that tell me summary information for all of this data. There are, again, over 35,000 matching subjects. Between them, they have over 200,000 files, and we can see what data commons those data come from. So lots of these subjects have data in multiple different data commons. Most of them are human, some don't have an answer, and there's 515 that must be from the dog data commons. We also have information about ethnicity, cause of death, race, format, which only has BAMs because that was our query, year of birth, and year of death. So we have built a simple cohort. It's just people that have BAM files, but that's not particularly helpful. Let's say that I want to do a comparison of BAM files between people that have tumor samples and normal samples so that I can look for de novo cancer mutations. So what I would want to do then is I would want to search for more things. So here I am going to add a bit of code and ask for columns and ask for all of the columns. So now I have lots and lots of columns. I have 64, and I want to know whether any of them have anything to do with tumors. I see that the file table has tumor versus normal information. The file table has tumor versus normal information, and that's exactly what I need. I'm going to do one more and look for the column values, just to make sure that I'm searching for things that I want. So if I hit the play button here, I can see that the only options are normal and tumor. So I'm going to use those to build new queries. I'm going to make a variable, and I'm just calling it normal, and that is going to hold all of my data that it matches tumor versus normal equals normal and format equals BAM. And then I'm going to make a second one called tumor and get all that subject data where tumor versus normal equals tumor and the format equals BAM. Then I make a third one where I'm asking for both, and I use the CDA option of intersect subject results, which takes all of the information that is in each of these and only pulls out the ones that have crossover. So I am going to intersect my results to get all of the subjects that have both normal and tumor BAM files. As you can see, that's still quite a lot of people. There's 22,000 subjects that meet that criteria. And if I scroll over, you can also see that my default view has added the column that I've searched on. So as I add more and more criteria to my search, it adds more and more columns to my output so that I can keep track of what I've been searching. As in the interactive view, from here I could copy these results, save them to a CSV, or save them to Excel. Or if I want to do this in the Python way, I can save them out using Python code. So that would be taking my both variable, sending it to CSV, and I'm naming this CSV BAMS tumor underscore normal.csv. I can save it out in any of those ways and continue to interact with these results later. Or maybe I want to keep going and narrow my results down even more. For instance, I could look for subjects that have the anatomic site of lung. So once again, I would have my normal, but now it's lung specific, so I've changed my variable name, and I'm matching tumor versus normal equals normal, format equals BAM, and anatomic site equals lung. And then for tumor lung, the only thing I change is that now tumor versus normal has to equal tumor. Once again, I can intersect my results, so I find only the subjects that have both normal and tumor lung tissue that has BAM files associated with it and look at those results. And this looks much more manageable. Now I have 315 entries, which is probably an amount that I could use for an analysis. You can see again that it's added anatomic site onto my query, so I have all of the information that I searched for, and I can save that out in any way that I like.